Good evening everyone. Welcome to my class. Good evening. Yes, last class I discussed about theory of PN junction diode. This class I am going to discuss few MCQ question based on the PN junction. Those who are not there in the live class, please see the recorded class. Okay. Let us discuss few important question based on the topic PN junction diode. MCQ questions. Yes. Yes. Hi Uma Devi. Let us discuss first question. Okay. First question. If the forward voltage in a diode is increased, the width of the depletion region dash. First option, whether it will increase or decrease, fluctuates and no change. Tell me the correct answer. Those who are there in the live. Uma Devi, are you there in the live? If you know the answer, guess the answer. If you don't know, answer the first question. If the forward voltage in a diode is increased, the width of the depletion region. What is the change in the width? They are asking in the question. First option, increase. Second option, decrease. Third option, fluctuate. Fourth option, no change. Here, in the last class, I explained in detail about the forward and reverse bias. I will explain once again because these questions, what I am solving here MCQ, purely based on the PN junction diode. After revising, easily you can answer the question. See, in the case of PN junction diode, in the case of a PN junction diode, you can observe here. Here, two types of semiconductor is joined, then we will get a PN junction here. Yes, what is meant by PN junction diode? P and N type. Okay, that semiconductor sandwiched we will call, otherwise joined together, we will get the PN junction diode. Then here consider p-type semiconductor and consider another one n-type semiconductor. Both joined, you will get the junction. This junction only we will consider as a PN junction. This is the P semiconductor, p-type semiconductor. This is the n-type semiconductor. You know, in the case of p-type semiconductor, holes are the majority charge carriers. Majority charge carriers means holes, they will involved in the generation of the current, otherwise it will plays an important role in the formation of the current also, you can consider. Then here electrons are the minority charge carriers. Minority charge carriers means they will be present in the less number. Then here in the case of an n-type semiconductor, the majority charge carriers are electrons, means you are having more number of electrons. These electrons, they will involved in the generation of an electricity. That is very important. Then here in the case of an n-type semiconductor, minority charge carriers are holes. Okay, I will represent here in p-type minority are electrons. Okay, this is the very important one you have to remember. In the case of p-type semiconductor, holes are the majority charge carriers, then electrons are the minority charge carriers. Then in the case of an n-type semiconductor, electrons are majority charge carriers, holes are minority charge carriers. That one is very important. Then these two conductor p-type n-type semiconductor, that one we will consider as an extrinsic semiconductor. These semiconductor we will get by doping. What is mean by doping? Doping is nothing but adding the impurities. When you add impurities to a particular semiconductor, that process we will consider as a doping. Then in the case of this PN junction diode, this is the forward bias. In the forward bias, positive terminal is connected to P junction, then negative terminal is connected to N junction. Then here already I explained in type of N type, here the majority charge carriers are electrons. Then in the case of P type, the majority charge carriers are holes. Then here when you apply an electricity, otherwise when you connected a battery, then here the electrons, they have the tendency to neutralize with the neighboring holes. Then this the electron, it will move in this direction, this also it will move in this direction, this also, because positive electron is electron is negatively charged, hole is a positive charge, they will attract each other, then they will get neutralized. Then here you will get a depletion region. Here you will get a region, otherwise this region we will call it as a depletion region. Here electrons, it will move, means it will lose the charge, therefore it will carries positive charge here. You know, any atom, if it is loses the charge, it will carry a positive charge. If anything, it will gains the charge, then it will carry a negative charge. That one you know. Consider an any atom, if electrons is removed from the atom, that atom we will represent like positive. Okay, anything you consider, that is a positive, otherwise consider any n plus or o plus. Okay, positive atom. Here consider n plus. If any atom, if it is gains electron, maybe consider any example o minus, otherwise o negative, then here you can, that concept only we are used here. We are having positive. Why we got a positive? Because electrons, they will lose the charge, therefore here positive sign you can observe. In the case of a hole, they will accept the electrons, therefore in this case you will get the negative charge. Then here you can observe, when positive charge and negative charge, it will create an electric field in the depletion region. Then this region, the electric field, it will move in this direction. Okay, then here the electricity, normally it will move from positive terminal to negative terminal. Consider here external battery also, the electricity, it will move from positive to negative, in this direction it will move. Then here you can observe the direction of electric field. Here you will observe the direction of electric field, it will be opposite. Both the direction of electric field, it will be in the opposite direction. Okay, here see, consider inside the depletion region, the electric field, it is moving in this direction. Then in the outside battery, the electric field, it will be in this direction, opposite direction. Because of this opposite direction, whatever we have this depletion region, we will consider this one as a depletion region. This it will be, what will happen? This it will be decreases because of the opposite side of electric field. That one you have to remember. Opposite side of an electric field, you will observe a depletion region here. Decrease in the size of the depletion region. Then when this depletion region decreases, then easily these electrons, they will cross the region. See here, if this depletion region, if it is become narrow, then the electrons in the n type, they can move through this region very easily. Then here in the p type, you are having the holes also they can move very easily. Then when you observe the movement of the charge carriers, then they will develop a current. Okay, therefore in the case of an PN junction diode, when you connect this diode in the forward bias, then here you can observe more generation of the current. Why you will observe the more flow of current? Otherwise, why you will observe more generation of current? Because here you will get, once you applied an external electric field, this depletion region, it will decreases. Why it will decreases? Because you will observe the opposite side of an electric field. When this region, if when it is become thin, then this electron easily they can pass the region. Once the electron flows, then it will generate an electricity. Electricity also it will move. Then let us discuss the graph, because this is also very easy. Whatever the questions I am discussing today, all the question based on the PN junction diode forward and reverse bias also. Okay, that's why I'm explaining once again. Then it will become easy for you when you are answering the question. Then here, when you draw the graph between IF and VF, voltage versus current, then when you increase the current inside this PN junction, then up to certain limit the voltage it will be constant. Then after, when you reach a certain value, the voltage it will become increases. This point we will consider as a knee voltage. This point we will consider as a knee voltage, or we will consider one more important word, that is threshold voltage. Okay, this one we will consider as a knee voltage, threshold voltage. Because why this, after a, why you will observe a sudden increase in the voltage? Because see here, already I explained here, because of the opposite side of an electric field, this depletion region it will become thin. When this region become thin at a particular voltage, when you increase the voltage from the external battery at a particular voltage, that depletion region suddenly it will become very narrow, or it will become very thin. At that case, when the depletion region, when it will become very thin, then the electrons they can move, they can pass through this region very easily. Okay, then in this, because of this reason, the the variation in the voltage it will be increases. Suddenly you can observe there will be a sudden increase in the voltage. Okay, then you can answer based on my explanation first question very easily. If the forward voltage in the diode is increased, when the voltage is increased, the width of the depletion region it will be decreases. The correct answer for this question it will be decreases, because already I explained all the reasons. In the case of an forward bias, the depletion region it will become decreased, because when you applied an external voltage, the voltage, otherwise the electric field, they will be in opposite direction. Because of the opposite direction, the depletion region it will get decreased. When the depletion region decreases, then the electrons they can flow very easily in this region, then it will constitute a current. That is in the case of an forward bias. Okay, reverse bias it will be like reverse of that one, that also you have to come to know. Let us discuss next question based on this semiconductor, diode and also insulator. The decreasing order of band gap energy is, see here, what is mean by energy gap? This also I explained when I did the semiconductor lesson, but no problem, once again I will tell. See, normally in the case of semiconductor, we are having two types of energy gap is there between the different energy level. First one we will consider as a conduction band, then another one we will consider as a valence band. Normally those electrons they will be present in conduction band, they will be involved in the bond formation. Okay, otherwise they will involve in the participation. Those who are there in the live, please tell me hi, then I will come to know who is there in the live. Only one person is there. Okay, how much possible share my link. Those who are like HSTR students, they will get make use of the videos, then they can prepare for their exam. Okay, then next one here, this is the gap between these two, conduction band and Fermion energy gap. This gap we will consider as an energy gap. Okay, band gap, energy gap, everything it will be same. Don't get confused. I am using the different word. Energy gap, band gap, everything it will be same. Then here the conduction band, those electrons if they are present in the conduction band, they will be involved in the generation of the current. That one you have to remember. Then in the case of a conductor, these energy gap, okay, I will read and I will explain. In a case of a conductor, in a conductor the conduction band is partially filled, the valence band is partially empty. When the conduction and valence band overlap, when there is overlap, electrons from the valence band can easily move into the conduction band. What will happen in the case of a conductor? I am discussing only about the conductor. What is the changes? What will happen in the case of a conductor? In the conductor, these two bands like valence conduction band, then next one valence band, they will be separate. But in the case of a conductor, both also they will get overlap. Overlapping figure I will right here only. They will get overlap like this, one above the other. They will get overlap like this. Valence band and conduction band, they will get overlap. Then there is no energy gap. You will observe there is no energy gap in this one. Then energy gap, it will represented by Eg, otherwise band gap, both also same. It will become 0 in the case of a conductor. Therefore conductors, they are good conductor of electricity. Normally conductors we will use, they are the good flow of electricity, good generator of electricity. Why means, what is the reason means, in the case of a conductor, both conduction band, valence band, they will get overlap. If electrons, if they are in the valence band, conduction band, both the electrons they will get interact with each other, otherwise they will be like overlapping. If more number of electrons, then they will create the electricity. Therefore in the case of a conductor, because of there is no energy gap between the conduction band and the valence band, the whatever the electricity current you are generating in conductor, it will be maximum or it will be high. That one you have to remember. Then whatever it will changes, it will happen in semiconductor insulator. Let us discuss. In semiconductor, there exists a finite but small band gap between the conduction band and valence band. Because of small band gap, at room temperature, some electrons from the valence band can acquire enough energy to cross the energy gap and enter the conduction band. Here, in the case of a semiconductor, here also we are having two energy levels. But here you will observe there is a gap between, that is the energy gap Eg. Eg, the energy gap, otherwise band gap, both also same, don't get confused. Energy gap between these two, this one is the conduction band, this one is the valence band. This is the energy level we can consider. This is the energy level we will consider. Then here you can observe a gap between the conduction band and valence band. Here the gap, it will be less than 3 electron volt. This it will be in the case of a semiconductor. That one you have to remember. In the case of a semiconductor, the energy gap between these conduction band and valence band, it will be less than 3 electron volt. Then here the electrons where they are present in the semiconductor, there exists a finite but small band gap between the conduction band and valence band. Yes, you can observe a small gap. Then you have to remember the gap value also. That also very important, because in the exam they may ask. Okay, the gap between the energy gap between the semiconductor, its value is less than 3 electron volt. Because of small band gap at room temperature, some electrons from the valence band, already consider some electrons are there in the valence band at room temperature, means normal temperature you can consider. These electron, because of less energy gap, easily they can move to the conduction band. Not all, at least few electrons easily they can move to the conduction band at the room temperature. Once you increase the temperature, all the electrons they may move, because you can increase or decrease conductivity based on the temperature. Okay, at a zero temperature, no electron will move to the conduction band, no electricity. Then at zero temperature, these semiconductor it will act as a insulator. This also I explained at 0 Kelvin. At maybe last class I explained this one. This is 0 Kelvin, otherwise the 0 Kelvin temperature. That is very important, because electricity, otherwise the capacity, conductance, everything it will be depends upon the temperature. At 0 degree centigrade temperature, this semiconductor it will act as a insulator. Why it will act as an insulator? At zero temperature, these electrons, the electrons they are present in the valence band, they will not move to the conduction band. Okay, when there is no electrons in the conduction band, then there will be no flow of electrons, then there is no generation of the current. That's why this is very important concept you have to remember. At 0 degree centigrade, semiconductor it will act as a insulator. Maybe in the exam they may ask MCQ questions at 0 degree temperature, the semiconductor it will act as a insulator. What is the reason? Anything they may ask. Okay, you have to remember the energy gap between this conduction band, valence band, that value is less than 3 electron volt. That also very important. That also you have to remember. Then at room temperature, these electrons, room temperature normally maybe 30 degree you can consider, maybe 27 up to 30 degree centigrade you can consider. This is normally we will consider as a room temperature. Normally we will consider 27 to 28. Even 30 also we will not consider. Even 27 we will consider as a room temperature. At this temperature, okay, 27 we will consider as a room temperature. At this temperature, few electrons are there in the valence band. Because of the increase in temperature, they will move to the conduction band. When the electrons they will move to the conduction band, then normally they will place an important role to generate an electricity. Okay. Next one, what will happen in the case of a insulator? Let us study. Remember here, in the case of an semiconductor, the value of this energy gap it will be less than 3 electron volt. But in the case of an insulator, this is the valence band, this is the conduction band. Insulator I have to write little more gap compared to the semiconductor. That's why I will write once again here. Okay, I will leave this much gap. This is the energy gap, E, G. This is the energy level, increasing level I am showing here arrow mark. Then here the energy gap, it will be more than 3 electron volt. In the case of insulator, you have to remember the energy gap it will be more than 3 electron volt. But in semiconductor it will be less than 3 electron volt. In the case of a conductor, the overlapping of 2 it will happen. Okay, that is the important one you have to remember. In an insulator, there exists a large band gap between the conduction band and valence band. Yes, you can observe a large band gap or energy gap. Okay, it will be more than 3 electron volt. There are no electrons in the conduction band and there are no electrical conduction is possible. Yes, there is no. Can you identify any electron in the conduction band? No, there is no electron in the conduction band. Some, maybe some electrons they will be there in the valence band, but here that electrons they may, because of this huge energy gap, they are not able to move to the conduction band. When there is no electron in the conduction band, then there is no flow of electricity, then there is no flow of electron first, then there is no flow of electricity. Okay, electricity maybe you are not able to generate. Therefore, answer the question now. The decreasing order of band gap energy, which one, which is the more energy gap according to my explanation. First one is insulator is having more energy gap, correct no? The energy gap between the conduction and valence band, it will be more in the case of an insulator. First it will be more. Second, semiconductor. Third one, it will be conductor. There is no gap at all in the semiconductor. Sorry, in conductor there is not at all a gap. Therefore, yes, Uma Devi, the correct answer for this question is insulator, then semiconductor, then conductor. Always remember, in insulator the energy gap it will be more than 3 electron volt. In case of semiconductor, energy gap it will less than 3 electron volt. In conductor, the energy gap it will be 0. That one you have to remember. Yes, answer next question. Yes, try to answer next one. A light emitting PN junction means light emitting diode can also be made to emit dash and thus can serve as a laser. Stimulated emission, spontaneous emission, spontaneous absorption, then induced absorption. Maybe this is the new words you are listening. That's why I will explain first, then tell me the correct one. Okay. First, let us discuss what is meant by emission. Spontaneous emission, stimulated emission. Maybe you don't know that one in detail. Then let us discuss first all the four cases. Then we will choose which is the correct answer for that question. Okay. Then here, what is mean by emission? Emission, the name itself, it is indicating anything electrons when atom when it will move from one energy level to another energy level, normally it will emit the photon, otherwise it will emit the electrons. Photon is nothing but the energy packets we will consider. Okay, see, light can be produced by the matter in an excited state, and as well will show excitation can come from various source. Yes, anything. Emission means, emission, the words it is telling, when light can be produced by the matter. Matter means anything which has mass and which occupy space. That one we will consider as a matter. When matter we will normally we will consider as an atom, particles. See, when you consider an atom, it contains nucleus at the center, then the electrons they will be revolving around the nucleus in a particular orbit. Everyone you know this one. Then here in the outermost orbit, even each and every orbit you are having the energy levels like this. See, even one orbit, if you consider, so many energy level, sub levels you have. Then here, see, once the atom, otherwise electrons, when it is moving from one energy level to another energy level, consider here, I have the atom here, otherwise I have the electron here. See here, this electron, if it is moved to the next energy level, then it needs some energy, no? Without energy immediately, simply it will not move to the higher energy level. Even consider one electron, it will be at the higher energy level, then it has to come to the next level. Then automatically, simply, otherwise without gaining, otherwise without losing any energy, no electrons, they will go to the different energy levels. Okay, here emission means if this electrons want to move to the higher energy or lower energy level, this is the higher energy compared to this electron, then lower energy means coming down. Okay, to they have to emit some energy. That one only we will call it as a emission. Even we will talk about an atom. Even the atoms, they will move from one energy level to another energy level. If you are considering a solid, solid is nothing but group of so many different number of atoms. All the process it will be happen in this way. Then here the atoms and molecules that make up matter typically emit light as a characteristic energies. If you consider one atom, this bigger atom I will consider, otherwise one solid if I consider, inside the solid you are having huge number of atoms, correct? No, huge number, uncountable number of atoms you have. Then here atoms and molecules that they will make a matter. Matter is nothing but, consider here solid you can consider, in this case what I am writing here, solid you can consider. Then here these atoms and molecules, when they are moving from one energy level to another energy level, even they have to gain the energy, even they have to lose the energy. Gaining and losing the energy we will consider as a, they will even emit the photon, even they will emit the, even they will absorb the photon, sorry, even they will absorb the photon, even they will emit the photon. Already I told, photon is nothing but packet of energy. The definition of photon is packet of energy. That's why if these electrons want to come to the lower energy level, otherwise if it has to move to the higher energy level, then it has to absorb the energy, either absorb, otherwise it has to release the energy. That one only we will consider as a photon. Either it will emit the photon, emission here I am explaining. Emission means it will emit the photon, absorption means it will absorb the photon. All the process it will happen with the help of the energy only, otherwise without supplying an energy, without losing the energy, no electrons, they will not at all change their place. If they want to change their place, they need some energy. Understood emission, everyone? Emission means to the electrons to go to the higher energy level or lower energy level, they need energy. Emission means they will emit the, they will liberate emission. Another word, even you can use the word liberate also. Next, in that one we are having the first type, that is nothing but stimulated emission. What is mean by stimulated emission? Let us discuss here. What is mean by stimulated emission? The process by which an incoming photon of a specific frequency can interact with an excited atomic electron, causing it to drop to a lower energy level. Consider an electron. If it is there in the higher energy level, already it is there in the higher energy level, then consider photon energy. Normally we will consider E is equal to h nu. This is the energy of a particular photon. E is equal to h nu. If this electron absorb this amount of energy, then it can easily come to the lower energy level. That one only here they are telling stimulated emission itself. The electron itself, it will not come to the lower energy level. We have to stimulate, we have to give the energy. Stimulate is giving the energy, otherwise initiating, anything you can consider. The process by which an incoming photon, yes, you are giving the energy in the form of a photon. This is the photon energy. This is the photon energy. Incoming photon of a specific frequency is h nu. H is the Planck constant, nu is the frequency. Okay, then you have to give the energy to a particular frequency. That also very important. Frequency mu can interact with an excited atomic electron. Yes, this electron already it is excited level. This level we will consider as a excited level. This one we will consider as a lower level, otherwise ground level. These orbits, they are like excited level only. These electrons already it is there in the excited level. If this electron has to come to the lower level, then it has to absorb the energy. That energy is nothing but photon energy, then causing it to drop to a lower energy level. Yes, this one after gaining the energy, it will come to the lower level. Maybe here it can come, maybe here also it can come, maybe here also it can come. Some possibilities, different possibilities there, based on how much energy you are giving, that also important. The liberated energy transferred to the electromagnetic field, creating a new photon with a frequency, polarization, direction of a travel that are all identical to the photon of the incident wave. See here one another one important thing. This electron, it will absorb the energy, then it will come to the lower level. When it is coming to the lower level, this electrons also it will emit photon. It will emit the photon. That photon energy level also it will be same as this one. E is equal to h nu. This electron after absorbing the energy, it will, when it is coming to the lower energy level, it will liberate the energy. That energy is nothing but this photon also. Okay, it will liberate one more photon. That one you have to remember. Then here when the electron, when it is coming from higher energy level to lower energy level, first it will absorb the energy, then it will come to the lower energy level. When it is coming to the lower energy level, it will emit the energy also. That energy we will consider as a photon. Always remember, when I will use the word photon is nothing but energy. That's why I wrote here photon is nothing but packet of energy. Even that electrons, first it will gains the energy, after when it will come to the lower level, it will emit same amount of energy also. Okay, that is very very important. This emission we will consider as a stimulated means initiating. Otherwise we are giving energy, otherwise okay, I will not give this energy to this electron. If I not given energy to this electron, that electron it will be remaining in that state only, it will not move anywhere, it will be remain at that level only. Okay, yes, tell me hi, who are there other than Uma Devi in the live? Maybe now onwards I have to send more, those who are there before, those who are there in HSTR group, I don't know their name, everything, phone number. If I know, then I can make a group, I can send them, but I don't have any contact. We will see how to reach them. If possible, you share my video, then they will come to know. Next, spontaneous emission. Spontaneous name itself it is indicating without energy, whatever the changes it will happen spontaneously without time gap. When an isolated atom is excited into a higher energy state, it generally remains in the excited state for a short time before emitting a photon, transi- transitionalizing to a lower energy level. Yes, Rajini, good evening. I am waiting for you only because afternoon only you told ma'am I will join the class. Okay, maybe you thought the class it will start at 6 o'clock. I told evening, but I not inform the time. Sorry. Okay, now onwards I will inform the Telegram group before. If you have your friends also, those are there in the HSTR group, please inform them. This is my own channel. That's why my name is there, no, Sunita Raghu. This is my own channel. In my own channel, I am doing the classes. This is not the paid one. You can watch my classes freely. Also, you can share to your friends, everyone, even your colleague, everyone. You can share. They can see my classes also. Okay, this is not the pay, no need to pay any amount to watch my class. This is I am doing like my own channel I am doing. Then how much possible share to your friends, teachers, then at least they will get the advantage of whatever the concept I am teaching. Okay, Okay, Rajin, now you join, no? Please, already half an hour over. Please see my previous. I will give the link. Already you have the link, no? Please revise the video. Okay. Okay, we will discuss. Next one, the name itself is indicating spontaneous. Spontaneous means without wasting time, immediately. Spontaneous means this is the lower level, this is the higher level. Higher level, this is the lower energy level, I will consider. This is the higher or excited. Once the electron, when it is moving from lower level to higher level, this electron, what will happen? Excited level it will reach, but immediately it will come to the lower level. That is spontaneously. It don't want to stay in the higher excited state. Spontaneously, within the shortage of time here, that's why I mentioned here, within the shortage of time, again it will come back to the lower level. Emission, we are talking emission, no? Therefore it is coming from higher level to lower level. Next one, let us discuss what is mean by induced absorption. Whatever the concept I am explaining, this it will be very very important, because more questions they will ask in this one only. Okay, that's why even MCQ I am explaining in detail, because this before I not explain this spontaneous absorption, then induced absorption, everything. You have to study this one in detail. Then next one, what is mean by induced absorption? A molecule in an excited higher energy level can spontaneously emit electromagnetic radiation returning to some lower energy level without the presence of inducing radiation. Yes, no need to give more extra energy. Induced absorption. Induced absorption. Here emission means emitting the energy. Here absorption, the name itself is indicating absorption means you are absorbing the energy. If the electrons, if they want to come from higher energy level to lower, or lower to higher energy level, they have to absorb the energy. That energy we will consider as a induced absorption. Induced means artificially we are providing the energy. Okay, don't get confused. Spontaneous means, induced means we are giving the energy. Spontaneous means here we will not give the energy. The electrons itself they have the energy. They are making the movement based on their own energy. Spontaneous, we are not providing the energy. But in the case of an induced, then in the case of stimulated, I told, no, stimulated then induced, remember the word stimulated, induced. Here we are giving the energy. We are giving the energy to the electron to move to, either to move to the higher energy level, either to come back to the lower energy level. We are giving the energy. Induced, then stimulating. Okay, but here spontaneously, when you see the word spontaneously, they don't want to stay in that energy level. Electrons itself they are coming. No, we are not giving the external energy. That one you have to remember. An atom in the lower level absorb a photon of frequency. Yes, photon, always remember the packet of energy. Don't get confused. Packet of energy h nu move to an upper level, spontaneous emission. An atom in upper level can decay spontaneously to the lower level. Decay means it can come back. Emit a photon of frequency h nu if the transition between E1 to E2 radiation. Here consider E1, E2, different energy level, E1, E2. Then here, when the electrons absorb energy in the lower level, it will absorb the energy, it will move to the higher level. Then spontaneous, it don't want to stay in that excited state. Once again, it will come back. When it is come backing also, it will leave the energy. That energy we will consider as a photon. Even that energy value is E is equal to h nu. When in your mind, when we will use the word energy, in this case you have to remember photon, that you have to remember. Okay, then now answer my question, MCQ question. I asked the question, a light emitting PN junction, emitting, Here they are given the word emitting PN junction, then can also be made to emit dash and thus can serve as a laser. Whether it is stimulated emission or spontaneous emission, spontaneous absorption or induced absorption. Now tell me the answer, which is the correct answer for this question. Tell me. Think. I explained everything. All the concept I explained. At least try. If it is wrong also no problem. At least try. Yes. Which type of emission? Tell me. Try. Whether it is stimulated emission, spontaneous or induced absorption. Yes, the correct answer is stimulated emission. Here only I underline the word no emission. A light emitting PN junction. Here they are emitting the light. Okay. Then here in the laser we will stimulate means we have to give the extra energy. Therefore the correct answer revise, no problem. This is maybe this is the first, this is the new concept for you. Revise, then you will come to know. A light emitting PN junction can also be made to emit dash, thus can serve as a laser, that is stimulated emission. Spontaneous no, we have to provide the energy. Spontaneous means this it will become wrong. Spontaneous also it will become wrong. Here absorption, but we are talking about the emission, this also wrong. The correct answer for this question is first one, that is stimulated emission. Don't miss each and every class, because here what we are discussing here, this one is based on the electronic. Electronics like diode, PN junction. Then after this one I will start um, which one, gates also I will start, energy gates. That's why electronic concept, at least don't miss the class. If you miss, then maybe you are not able to follow anything. It is very difficult for you. Okay, next question. This one it will be easy. The forward bias diode connection is, yes, in the forward bias the connection is, in the forward bias already I explained. What is the, no problem Uma Devi, we are learning this one. I don't know, already I don't know, electronics will we not learn these concept, this it will be difficult. No problem, revise one or two times, then you will come to know. Yes, yes Rajini, fourth one, very good. Fourth is the correct answer, because in the case of PN junction diode, see positive terminal, P junction is connected with positive terminal, then N junction is connected with negative terminal. Here you can observe this is the P junction. This arrow mark it will indicate P, then this is the N. Then here P junction is connected to positive terminal, N junction is connected to negative terminal. Therefore, fourth one is the correct answer. Very easy question. If you don't know the terminals properly, maybe here when you see this positive, negative, you will get confused. Therefore, remember. Okay. Here also I explained the positive terminal of the voltage potential is connected to P type. Then negative terminal is connected to N type. P is connected to positive. Yes, no? Then N is connected to negative. In the case of a forward bias, reverse bias, it will be like opposite to that one. Yes, let us move to the next one. Yes, answer this one. Rajni, after the class, you can mail me your number to my email address. Then I can make a group. Whatever the classes I will do, you will not miss even one class also. I will intimate personally. I will tell the, I will, I will forward the link. Then it will be easy for you. Not for you, at least those who are preparing for HSTR. For them, it will be easy. Okay, answer this one. The resistance of a PN junction in forward bias is, what is the resistance? Resistance is nothing but a opposing force. Answer the question, at least try to answer. See here, in the case of a PN junction in the forward bias, this is PN. When you connected this one to external battery, then this junction, it will become narrow. I told it will become narrow, it will become thin. Okay, when this junction it will become thin, then here you can observe easily the electrons here. This is the N type, this is the P type. In case of N type, electrons are the majority charge carriers. Yes, holes are, in the case of P type, holes are majority charge carriers. When this junction, if it is very thin, then these electrons easily they can move. Correct? No? Then easily they can create an electricity. Then here the resistance is nothing but here the opposing force they are asking. If the depletion region is very thin, opposing force is less. If this depletion region, we will consider this one is the depletion region or layer. Okay, if this layer is thin, then resistance it will be resistance it will be less, or opposing force also you can consider. This it will be very less. Then answer my question. I explained. Think. It is not zero. Think. The resistance of a PN junction in forward bias. I told they can cross very easily. I not told it will become zero. Easily they can pass, means the resistance it will be very low, not zero. Resistance never it will become zero, because some opposing force it will be there, because depletion region is there. No, if this one is not there, without this region not there, means easily they can pass, but some resistance it will be there, that value it will be very low. Understood? Umadevi understood now? This value, opposing force is there, resistance is there, but it will be very low. Then move to the next question. That one only I, whatever I explained, that one only I put it in the words. Don't worry, I will send even PDF notes also. First I will make a group, then once group is created, then I will send the PDF notes. I am planning, I will take the classes, HSTR classes, uh, this month and next month also, because after June I don't know whether I can do it or not. After once the school start, maybe I will not get the time to do the classes, but I will try to finish whatever the portions I have in physics, remaining 3 lessons. Then 50% of maths I am not completed, that I will do. Okay, that's why be touch with me now onwards. Each and every day, one maths class compulsory I will take, one physics class compulsory I will take, because I will be free now. I don't have any schools, even I will be free from school work, no, therefore I can concentrate more classes. Even I will get more time to do all my work. That's why. Okay, don't miss. I'm trying to finish the classes how much possible. Okay, we will discuss more MCQ questions also. And there is no time limit. Exactly 1 hour I have to finish the portions. Not like that. If I am free, I will continue 1.5 hour. It will be depends upon the concept. Otherwise, how many questions I am choosing, that also it will be based. Okay, making use of that one. Then you also start preparing at least these 2 months. Now everyone are telling HST are definitely after the election they are going to call. After the election means maybe in the month of June, definitely they will make a notification. Then maybe after the notification, maybe 1 month or 2 month they will give the time. How you can read the entire portions within one month or 2 month? It is impossible. That's why now you have the more time, even holidays also there. That's why try to finish the portions for one time, then try to solve more MCQ problems. Okay, I will help you, don't worry. I will be available for you more than 10 hours per day. If you have anything, any questions, anything, if you want to ask, you can mail me. Once I will create the group, I will give my phone number also. You can contact me directly. Okay. Okay. Then next one, what is the cause of formation of depletion layer at the PN junction? Already we know in the PN junction the layer is there. Then what is the reason of forming that one? Because of the potential difference between the points, diffusion of charges, impurity in the semiconductor, then all of the above. Tell me the correct answer. Here in the case of PN junction, you are having the, yes, in this one PN junction you have the depletion region. Here you have PN. What is the reason of forming here? Why this depletion region it will form? Answer to Rajini. Okay, I will explain later. You will only change your option. Don't worry. Then here the electrons are majority charge carriers. Yes. Here the holes are majority charge carriers. Yes. Then here the electrons they will move here. Therefore here positive charge it will form here. Here the negative charge because the holes they will accept here electrons. Then here it will create an electric field also. This is the electric field. Positive means normally it has higher potential. Yes. Negative means lower potential. Therefore your first option, potential difference between the 2 points. Yes, this also it will plays an important role in the formation of depletion region. Diffusion of charges. Yes, this one also you can see the formation of charges. This electron it will lose the, here the electrons when it is moving, when it is neutralized with the hole electron it will lose the charge. Okay, therefore it will become positive. Holes it will gains the charge, therefore it will become negative. Both positive negative they will get neutralized, correct? No. Then diffusion of charge, otherwise movement of the charge, everything is same. Then here p type, n type, this semiconductor we will consider as an extrinsic semiconductor. How you will get this extrinsic semiconductor? By adding impurity. By adding impurities we will get n type p type semiconductor. Then here the third option also correct. Then tell me Rajini, what is the correct answer for this question? Now you can tell me what is the correct answer for this question. Tell me, because this one it will include, even you will observe in the potential difference between the points also. One is positive, negative, even diffusion of the charges also it will happen, even impurities semiconductor. Therefore your answer is fourth one, all of the above. All of the above is the correct answer. Understood now why fourth option is the correct one? Because definitely like this question they will ask in the exam. To formation of the depletion region, why it will form? Because of the difference in the potential difference, even it will create an electric field, diffusion of the charges, flow of charges. Then even adding impurities p type, n type. How we will get the semiconductor? By doping. Doping is nothing but, even adding impurities we will use the word doping also, we will use everything, it will happen. Okay, already 1 hour over, I will move fast. Whatever I explain I put it in words. Okay, here then Once I will provide the PDF notes, you can revise. Next question. Now onwards it will be easy. The reason of current flow in PN junction in forward bias is why the current it will flow. What is the reason why it will flow? Drifting of charge carriers, drifting of minority charge carriers, diffusion of charge carriers, then all of the above. Tell me. Drifting word, we don't have any word like drifting, correct? No, that is the wrong word. Then diffusion of charge carriers, option 3 is the correct answer. Drifting voltage we will use that, but we will not use diffusing, we will use diffusion, we will use drifting. No, even if they given even diffusion of charge carriers, then this may correct, but compared to these two, this is the wrong word. Okay, the next one, diffusion of minority charge carriers, this one we will use in the reverse bias, not in the forward bias. This it will be correct answer for reverse bias, not for the forward. Here they are asking for the forward bias, therefore the correct answer for this question is diffusion of charge carriers. Rajini, Uma Devi, if you are not attended my last class, I explained PN junction theory class. That time also no one is there in the live. That link also already they are provided you. Better one more time you revise that one. Then it will be easy for you to solve this one MCQ questions. Okay. Then here, the correct answer for this question is diffusion of charge carriers. Here, even the charge carriers are holes and also even electrons also. Both also they will play an important role. Charge carriers means we will both the words also we will use. Okay. Then in the reverse bias, we will use the only the minority charge carriers. Minority charge carrier means those who are there in the less amount, because this electronic is easy, but you have to at least revise 2-3 times, it will be easy for you. Then move to the next. In forward bias, the width of the potential barrier PN junction, otherwise depletion region, don't get confused. Even potential barrier they will use, even depletion layer, all the words are same, don't get confused. It will increase, decrease, remains constant, first increase then decrease. At least this one you can answer. Tell me the correct answer. Yes, at least this one you can answer. Very good Rajini. Yes, already I told in the case of forward bias, yes, the depletion region it will be decreases, but in the reverse bias it will get increased. Okay, that you have to remember. Why it will get increase in the reverse bias? Okay, I will explain here only. In the case of an reverse bias, consider this is the PN junction. Then here you can see the region, big one we will get here. Here electrons are the majority charge carriers, here holes are minority. Okay, then here holes are majority, then electrons are minority. Why this one it will become big means, here only this minority charge carriers, electrons it will move in this direction. Sorry, electrons it will move in this direction. Here holes they will move in this only minority means they are very less, correct? No, only less amount of energy, less less flow of less flow of electrons. When less flow of electrons, then whatever the electric field is generated here, electric field also very less, electric field also it will become less. When electric field is less, then here the electrons they can't move here in this depletion region. When they are not able to move because of less electric field, this depletion region it will become very big. That's why I explained in detail in the last class. reverse bias, forward bias, everything. Once again you revise, it will be easy for you. But I told here brief within a minute, but I explained detailedly in that video. Better refer that video. Okay. What is the meaning of doping? Now only I told. Answer properly. Someone now joined me. Tell me who joined other than Uma Devi, Rajni. Here showing. Yes. Yes. What is the meaning of doping a semiconductor? Yes. Yes. Adding impurity to it. Very, very good. Very good. Doping is nothing but adding impurity to it. Yes, I included everything here. What is meant by doping? Can you listen properly, Rajini? Can you hear me properly? Because from last 1 hour I started, no one asked me. Only two three are there. I don't know. No one asked me whether it is audible or not. That's why I'm asking. For a reverse biased PN junction, yes, this question is based on the reverse biased. P region is positive, the current is due to electron. P region is positive, the current is due to holes. Third option, P region is negative, the current is due to electron. P region is negative, the current is due to both electron and hole. Tell me what is the correct answer for this question. In the reverse bias, yes, it is clear. Okay, then answer the question. Yes, no need to check all these options. Okay, normally in the whether it is a reverse bias or forward bias, whatever the current is due to both electron and holes. Here no option have the both electron and holes, only this option it has P region is negative and also both electrons and holes. Because in the beginning of the class only I told, in the case of a diode, normally we are having two types, forward and reverse bias. In both the diode also we will get the electricity. We will generate the electricity. Here the charge carriers are electrons and holes. Before we know, only electrons they will involved in the movement of the otherwise generation of the electricity. But here we will come to know, in case of a diodes or semiconductors, even electrons and holes they will play an important role. Therefore remember that one. Next, answer this question. This also very easy. In forward biasing of the PN junction. Yes, this already you know the answer. Do it. The positive terminal of a battery is connected to P side and the depletion region becomes thin. This option 1 is the correct answer. Because very easy, I don't want to explain. It will be easy because forward bias the positive terminal is connected to P side. Yes, no? The depletion region is very, very thin. Here, next option, the positive terminal battery is connected to P side, it is there. But depletion region become thick. No, this is wrong. Then positive terminal connected to N side. This is wrong. Then last option, the positive terminal of the battery is connected to N side. This N side is itself is wrong. Therefore, the correct answer for this question is option 1 is the correct answer. Next, move to the next question. Otherwise, Rajini, I am giving my number. Shall I give or not in the public? Okay, you ping me in the whatever the mail I will give. No, in the mail you mail me. I will add your number because I don't know this YouTube. It is going live. That's why I don't want to give my mobile number, but you ping me personally, I will give my number. Okay, next. In a PN junction diode, change in temperature due to heating. Yes, a PN junction diode, change in temperature due to heating, affects only reverse resistance, affect only forward resistance, does not affect resistance of PN junction, affect the overall VI characteristic of a PN junction. Email address you don't have, I will give the email address. Write down Sunita 16 dot Siddharaju at gmail.com. Okay, this is my mail. Then you can ping me. I will give my personal number. Sunita 16 dot Siddharaju at gmail.com. So, okay, in a PN junction diode, the change in temperature is due to heating. Tell me the answer. Affect only reverse resistance, affect only forward resistance. It will, option fourth is the correct answer. Even see here, even reverse bias, even forward bias also, whatever we are discussing, the changes it will be between V and N. The changes it will be between V and N. The graph you will get the different graph. I will include it the graph also in the last class. See that one. Whatever the changes, when you increase the temperature, the value of voltage, the value of I, both also it will get changed. That one you have to remember. Yes, explanation I given. Read that one. PN junction diode works insulator if connected to. In which case the PN junction it will be work as a insulator. In which case, in which particular case it will be acts as a insulator. When it is connected to AC, AC means alternative current. When it is in forward bias, when it will be in the reverse bias, when it will be fourth option, none of this. In which case PN junction it will be behaves as an insulator. Option 3 in the reverse bias. See, when it is connected to AC, no. AC, DC, it will not come here in the forward bias. In forward bias, yes, it will not at all act as an insulator, because forward bias we will get more amount of electricity we will get. Therefore, this option is wrong. Then the correct answer for this question, in the case of an reverse bias, the PN junction it will be acts as a insulator for only for particular time. After once you increase the temperature, then there will be a flow of electrons, it will happen. Minority charge carriers it will happen. Then it will create an electricity. That is the different one you have to remember. Okay. The next one, next question, last question, today's last question. Diode is used as a, how we will use the diode? Diode here we will use as a rectifier. Diode we will use as a rectifier. Then let us discuss what is mean by rectifier. I will explain here. Rectification. A rectifier is a device that converts alternating current into a direct current. That process we will consider as a rectifier. Therefore, this diode it will used as a rectifier because it will convert alternating current to DC current. Therefore, it will act as a rectifier. Okay. Okay. Thank you, everyone. Thanks for listening my class. This it will become a like more than 1 hour 15 minutes over. Now onwards I will make less than an hour, because today I explained more. No, that's why it took more time. That's why those who are share my video to your friends, and those who are preparing for HSTR, JPSTR remaining also, it will help for them. Okay. Thanks for listening my class. Thank you everyone.